Hello, everybody. Today, we are going to delineate the PFD of the Zafar platform. Let's start. Developing the complete flow diagram of any platform system requires enormous amounts of work and true data. Therefore, most of the process engineers spend hours and hours to gather all of the required values and then, in the end, generate a full system after millions of updates. On the whole, the platforms comprise mainly of separators and pressure-creating devices. In our Zafar platform, two-phase mixtures from LP low pressure and HP high pressure manifolds enter corresponding separators in order to remove liquid and gas parts of the mixture from each other. To be more precise, the mixture entering the HP separator working at 40 degrees Celsius and 2901 kilopascals is processed under high-pressure conditions, and then its depressurized liquid from the bottom part of the column comes into the LP separator working at 35 degrees Celsius and 1401 kilopascal. Moreover, the bottom product of this column is the liquid which needs to be transported to the onshore for further processes or for a direct sale. As the distance between the offshore platform and the onshore terminal is huge, the liquid needs to have a certain level of pressure value to overcome the sum of pressure losses on the way and the pressure at the entering point. This pressure is generated with the help of two consecutive pumps. The first pump, booster pump, which is slightly smaller, serves for increasing the pressure of the liquid to the determined mid-pressure value of 2800 kilopascals right before the entrance of the main pump. This pressure increase is especially determined through several steps of calculation and aimed to prevent the formation of the cavitation, meaning high-pressure collapse of bubbles formed due to the boiling of the mixture at low pressures in the pump. After that, the second pump, mole or main oil line pump, increases the pressure of the export fluid to 6601 kilopascals, which is quite enough for the liquid to reach the onshore terminal. At the same time, the vapor leaving from the top of the column gets into suction scrubber 1 that removes all of the considerable liquid particles from the vapor before entering into the flash gas compressor FGC. The compressor, whose main purpose is to bring the vapor to the same pressure as the vapor leaving from the top of the HP separator, increases the pressure of the vapor from 1401 kilopascals to 3101 kilopascals. However, immediately after going out of the compressor, the vapor enters into the cooler to give its excess heat away prior to joining with the HP vapor. Once these vapors are mixed, they once again get into the cooler for farther removal of the heat till 16.12 degrees Celsius. Unfortunately, all of the cooling procedures result in the creation of the liquid particles inside the mixture. These are removed in the inlet scrubber of the glycol contactor, where the components which cause the formation of hydrates are separated from the mixture with the help of glycols. This system takes advantage of the glycol regeneration system, where the glycol mixture used in the system is regenerated. Subsequently, the hydrocarbon fluid which gets out of the contactor enters into second suction scrubber, which removes liquid particles, and then it mixed with the scrubbed liquids from the first and inlet scrubber. After that, this whole mixture is dispatched to the flare system. Simultaneously, the vapor of the second scrubber is transferred to the gas export compression, where its pressure gets increased to 7101 kilopascals. As a final stage, the vapor is moved to the onshore through the export pipelines. Thanks for watching.